Hello guys, I'm Sneha S from Department of CSE Cybersecurity from Shri Venkateshwara College of Engineering. Today I'll be discussing about a topic called vector space in Mathematics 2. So what is vector space? Vector space refers to a set of vectors that satisfy certain properties under vector addition and scalar multiplication. Vector addition means to add two vectors, and scalar multiplication means to multiply a real number to a matrix that is nothing but a product between a real number and a matrix. Let us see the properties of vector space. A vector space must have a zero vector denoted as 0, which is an additive identity. So why should a vector have a zero vector? It should have a zero vector because later it should be a subspace in the vector, and additive identity means whenever you add 0 to any number, the result remains same. Next, a vector space must be enclosed under vector addition, meaning the sum of any two vectors should be in the given space. And a vector space must be enclosed under scalar multiplication, meaning that the product of any two scalar vectors should be in the space. Next is an example for vector space. The set of all n-dimensional real vectors denoted as r cap n is a vector space. The set of all polynomials of degree at most n denoted as p underscore n is a vector space. The set of all continuous function on a closed interval a comma b denoted as c of a comma b is a vector space. Now let us see what is vector field. Vector field refers to a set of numbers that satisfy certain properties like addition, subtraction, multiplication, and division. Properties of vector field. A vector field must have two operations, that is addition and multiplication. Addition in a field must be commutative, associative, and additive identity. Multiplication in a field must be commutative, associative, and have a multiplicative identity. So these are in addition, there are three properties, that is associative, commutative, and additive identity property, where we see a plus b bracket plus c gives a plus bracket of b plus c, that is 4 plus 2 plus 1 gives 4 plus 2 plus 1. No matter how you add, you get the result as same. Commutative property also means the same, where a plus b is equal to b plus a, that is 4 plus 2 is equal to 2 plus 4, with the sum remains same, that's 6. And additive identity means when you add 0 to any number, you get the result as the same required real number. Next, let us see multiplication properties. Here we see four types of properties, that is associative, commutative, multiplicative identity, and zero product property. Associative property means when you multiply a into b into c or a into b into c, even with the brackets, you will get the same result. Commutative property also, a into b is equal to b into a, that is 4 to the 8 and 2 4 the is also 8. Multiplicative identity property of 1, when you multiply 1 to any real number, the result remains same, and when you multiply 0 to any real number, the result becomes 0. Inverses, additive inverse and multiplicative inverse. To a given real number, when you add the negative of that number, it gives you 0. And for multiplicative inverses, when you take a number and reciprocate the given number, you get the result as 1. That is multiplicative inverse. Now let us see example for vector field. The set of real numbers denoted as R is a field. The set of complex numbers denoted as C is a field. The set of rational numbers denoted as Q is a field. Now let us see the applications of vector field and space. Vector field and space maths are used in various fields such as physics, computer graphics, and engineering. They used to represent and manipulate physical quantities, analyze geometrical structures, and solve systems of linear equations. They provide a foundation for more advanced concepts in linear algebra and mathematical analysis. Now let us come to the conclusion. We all know that vector space and field maths are essential concepts in mathematics, especially in linear algebra. Understanding vector spaces and fields allow us for the analysis and manipulation of vectors and numbers. These concepts have wide-ranging applications in various fields and are crucial for further studies in mathematics and related disciplines. Here is a simple example for vector space. That's all. Thank you so much.